what I was going to talk about is this issue of part of agency. So goal directedness is really critical, problem solving, but also this autopoietic step of knowing or estimating for yourself, having a model of where you end and the outside world begins. So this issue of sort of informational self-construction. And one model I have for this has to do with early embryogenesis. So imagine you're a blastodisc of, I don't know, a bird or a human, some kind of amniote, and you're a disc of about 50,000 cells, something like that. And typically we look at this thing and we say, okay, there's one embryo, one individual. It's going to be one agent. It's going to be a duck or a human or whatever it's going to be. But what are we counting when you say there's 50,000 cells? What do you count? When there's 50,000 cells, there's one embryo. When you say there's one embryo, what are you counting? So what you're counting is the reliable alignment of all the cells towards a specific path in anatomical morphospace, meaning that left to its own devices or even perturbed in various ways, all of the cells will work together to make exactly the right thing, whatever the target morphology for that species is. And you can do all kinds of stuff and move things around and they'll move back. And, you have there's all kinds of ingenuity there about getting to where it needs to go. But that's what you're counting, is that there's one job to be done to build this particular thing. And we all know what it is. But it's actually much more interesting than that, because what you can do, and I used to do this as a grad student with duck embryos, you can take a little needle and you can make some scratches into that blastoderm. When you make the scratches, you separate it into several islands, let's say two or three. And that early system that aligns cells towards being one embryo, it's got this, among other things, what it has is this ability of local activation, long-range inhibition, such that, there's an organizational, a few cells become the organizer and they tell everybody else, you guys are not the organizer, I'm the organizer. And then they sort of organize the embryo. So when you separate this thing into disconnected islands, basically each one of them can't feel the others because there's an empty space between them. Later they will heal, but until that happens, each one is an individual and each one becomes a separate embryo. And when they do heal, you get twins or triplets. And so now this is very interesting, because if you think about that 50,000 cells, every cell is some other cell's neighbor. So the question is, where is the agent, right? And there's three of them now that's even more interesting, because there are some cells on the boundary and they're sort of confused about who they belong to, right? And there's all kinds of medical implications of that I used to study. And so there's this idea that the number of agents or selves in this medium, it's like this kind of excitable medium, or this Freudian ocean of potential selves. There could be 0, 1, 2, 3, maybe up to half a dozen in a typical blastoderm, and you don't know how many there is. It isn't preset. It's not preset by the genetics. It's not preset by the hardware. It's an emergent fact of the physiology, where some number of selves will demarcate themselves from the outside world. And so I really like this, and I really like thinking that what's important, and that's just one thing that's important beyond goal directedness, but there's some other stuff, but that process of delineation of a self as separate from the outside world, and the fact that you have to do that yourself, as opposed to a lot of our robotics and AI where that's given and predetermined from the outside. The agent doesn't have any choice about it. This is your limits, and that's it. Yeah. Right. That I think is very important, and it has all kinds of implications in biology that lead to a lot of the cool things that we like about biology. One of them is this weird intelligence ratchet, which is this. First, I'll tell you about the ratchet first, and then how it relates to all this. So the ratchet is this. Imagine that one of the funny things about planaria, these flatworms, is that they're incredibly regenerative, very reliably regenerative. They are cancer resistant. They are immortal. Basically, they don't age. And yet they have a really chaotic genome. And the reason is because when they divide, the way they reproduce, unlike us, if we get a mutation in our bodies, our children don't automatically inherit that mutation, right? In the planaria, they rip themselves in half, and then each half regenerates. So that's how they mostly reproduce. And there are other species that do sperm and egg, but there are species that just regenerate. And so that means that any mutation that doesn't kill the cell is amplified into the next generation and makes up the body. So they can be mixoploid. Every cell could have a different number of chromosomes. It's incredibly messy on the hardware end. And yet the animal with the messiest genome is the one that has the most cancer resistance, regenerative ability, and less aging. So that seems really strange, and that bothered me for many years. How that can be? Why is the animal with the noisiest genome that has the most morphological stability? And so recently we kind of studied this in a computational way, and I think we finally have a little bit of insight into how it works. Because this whole process, this evolutionary process, is not dealing with a passive material. It's dealing with cells and tissues that themselves have various agendas in physiological space and anatomical space and so on. What happens is that for an example, if I take a tadpole and I move in the embryo, I move the mouth off to the side, right? What happens during development is that it fixes itself. The mouth will come back to where it needs to be. So if you had a mutation that made that change, your fitness is not zero because you can't eat. Actually, your fitness will be fine because the mouth will come back. And so the ability of the cells to make up for these kind of weird mutations and other problems means that it's quite hard for evolution to gauge the quality of the hardware. When you come up for selection, if you're a pretty good tadpole, selection doesn't know whether you're a good tadpole because your genetics was amazing or you're a good tadpole because your genetics was so-so, but you fixed it, right? The structural genome was but the competencies fixed it up. So that means that the evolution has a hard time improving, even with a little bit of competency. Evolution starts to have a hard time improving the structural genome, but what it can do very easily is improve the competency. But when you improve the competency, it becomes even harder to gauge the actual structural genome. And that means all the effort goes into increasing the competency, and so on and so on. So you get this positive feedback loop where the more competency in the individual parts, the less emphasis and the less pressure goes onto the hardware, meaning the genome, and the more onto this actual competency. It's like Steve Frank once gave me this great example of he said that once RAID arrays started being popular in computers, the quality of the actual disks has gone down because you don't need to have great disks anymore because you have a RAID array, right? So the pressure on having really low error media goes down. So it's something like this. The pressure is released because of the competency. So if you're a planarian where you know for a fact that you really can't rely on your genome being very clean, right? Your hardware is unreliable. You really all the pressure is on to develop an algorithm that makes a good worm, no matter what the hardware looks like, but with limits, obviously. And this actually explains a very weird, sort of fact, which is that unlike most other creatures where you can get mutant lines, right? So flies with curly wings and albino, rats and things like that. There's no such thing in planaria. There are no abnormal lines of planaria except for the two-headed form, ours, and those are not genetic. Those are made by altering the bioelectrical memory, there's nothing genetically wrong with them. So all of that bring us back to the original discussion. So all of that means that you really, because you can't know ahead of time as an embryo, you can't know ahead of time, do I have the right number of cells, the right size of cells? Is my DNA okay? You don't know any of this. And there are many examples in biology where, embryos construct themselves despite all sorts of crazy variabilities. It's because none of this is baked in. You have to solve these problems on the fly. So however many cells, bigger cells, smaller cells, they're very good at nature. Evolution gives us these problem-solving machines. It doesn't just make specific, solutions to specific environments. So because of that, because of this need to solve this thing from the word go, I think that the kinds of things that we associate with biological agents are part of this intelligence ratchet, where in different spaces, some of it visible to us, some of it we're very bad at noticing, but there's this constant ratcheting of problem-solving capacity because they have to do this, because no one is there to reliably tell them where do you end, what are your sensors, what are your effectors, what space do you work in. No, it's all up for grabs, right? No life form that took that for granted could really survive nowadays. Maybe early life did, but nowadays that wouldn't fly, with all the competition. So anyway, so that's my very long answer to your point.
Oh, okay. So yeah, in essence, we have agential matter that has evolved over billions of years that have this competency that it can solve these different problems for keeping itself alive, essentially, or having itself grow. right? But you're always beginning with this kind of matter, which a deep learning system will not have or does not have.
Yeah,
Right?
yeah, right.
It's just calculus and algebra essentially, right?
Yeah, I mean, right. So the things that I think are important is that it's a multi-scale system where at every level, like I give this talk sometimes called "Why Robots Don't Get Cancer," right? It's because our current technology, it only has intelligence or some degree of agency at one level. The parts are pretty dumb. It's the whole robot that you hope has some intelligence. Biology, every layer is a problem-solving kind of thing. So that's useful. The fact that it has to construct itself from scratch every time is useful. The fact that it's always metabolically on the edge of starvation. Basically, it constantly has to find energy, which means that it has to be really good at doing causal coarse graining on the environment, or else it'll die. Like all of these things. So that's what makes it different from current devices. But I really believe that it's not. There isn't a fundamental divide, as in, we will never be able to, engineers will never be able to duplicate what. I don't believe that's true, actually. I think today's technology doesn't do this well. That's true. But I don't see any reason why, if we learn the lessons correctly from biology, and I'm sure there are others that we don't know about, I don't see any reason why we couldn't engineer this way later. And in fact, I would Jamie Davies and I wrote this thing called Engineering with Agential Materials. Like, I don't think it's unreachable for us. I don't think it's magic. I don't think evolution has a monopoly on this. I think engineers could do this, but I do agree that today's technologies are not this kind of system. They're different.
Yes, yeah, I don't disagree with that. I agree that if they train these systems with a particular curriculum, such that it needs to essentially survive, then it will learn the heuristics to do that.
Yeah.
And then that would get you to an AI, an AGI with agency.
Yeah, with stronger, and I mean, again, I don't like binary categories on almost anything. So, I think they have extremely low agency, but I think I think it's possible to make ones with more. I don't know that it's I think that we have to be ready also for the fact that, I mean, up until now, all of these things tracked very well together. So anything that spoke, you kind of knew that it went through it had the same existential struggle that you did. It went through the same, you kind of could make all these assumptions. So now, for the first time, we see some truly diverse intelligences. We see some things that are problem solving agents that are not like us at all. And, we're now finding that in fact, you can dissociate some of this stuff. And I think it's really, a lot of people are finding it really hard to get away from this binary vision that either it's a dumb lookup table or it's just like us. Those are not the only options, right? There's a diverse, there's a huge space of possible minds that with different failure modes and different abilities, and some of them look like us and some of them don't, and it's easy to be fooled. But I think the solution to all this is, kind of a proper grounding in the diverse intelligence field, where you start to understand that these are not our only options. There are many ways to have a kind of mind, and we're going to have to learn to relate to all these things in a useful and ethical manner.
Yeah, I think one of I guess the problem has been that the only general intelligence that we are familiar with are humans, and cognitive psychologists have built their models based on humans that have agency. So they can't conceive of a general intelligence that is devoid of agency.
Yeah.
It's not in their current models. Now we have something that appears to be generally intelligent, but it's completely devoid of agency.
Yeah. I think this one of the biggest issues is that all of our kind of major sense organs are pointing outward in the three-dimensional space, and we're very good at noticing medium-sized bodies moving at medium speeds in space, and saying that, oh, look at, here's a crow or an ape or an octopus doing something clever, and we can recognize some intelligence that way. Imagine if you had a primary sense of your blood chemistry. if you had another sense, kind of like taste, but sort of, more, but aiming inwards into your blood, and a little and richer, kind of like almost like vision. I think if we had that sense and we sort of grew up with it, we would have absolutely no problems recognizing that we also live in a physiological state space, and that our kidneys and our liver are these amazingly intelligent agents that navigate that space, because we do, challenge them with various stresses throughout the day, and they do all kinds of interesting things, and they navigate this space and solve problems for us and so on. We just have a really hard time envisioning intelligence in other problem spaces, right? But I mean, humans are kind of general intelligences, yes, but like we as humans don't typically solve problems in some of these other spaces where individual cells, bacteria, and other things do very well. So I feel like this kind of human-centered approach is really blinding us to a lot of examples of intelligence out there, and that's why people are so freaked out about suddenly being confronted by this, kind of linguistic intelligence. I mean, these radically different minds are all around us all the time. We're just very bad at noticing it. So, yeah.
Yeah. So what do you make out of the argument that if we continue to go on this path of accelerating AGI, that it's an existential risk to humanity? Does that make sense?
Yeah, I mean, well, I guess a couple of things. We have many things that could potentially pose an existential risk that are not necessarily like us or agential or whatever. There are many ways that we could kill ourselves off, right? I think it's not impossible that if we don't learn the lessons of diverse intelligence, if we fail to understand how properly to relate to these things, that we could end up really, really having problems. I don't think that's impossible. At the same time, I don't think the solution is to try to stop research in some way. I think it's impossible, even if if it was a good idea, and I don't think it's a good idea. I think that if it does end up causing a major problem for us, it's going to be because it's not going to be because of anything it does. It's going to be because of our refusal to learn to relate to other kinds of minds in a novel way, right? All we know is how to relate to other humans. Barely. We can sort of relate to animals, not very well, but kind of, and that's it. And we're really not willing to understand anything else. And at that point, yeah, I think if we don't learn that lesson, we're gonna have a major problem. But not even just because of the AGIs, the kind of computer intelligence. I really think because of all the biotechnology and advances in biorobotics and things like this, we are going to be surrounded by, and certainly our children will be surrounded by, beings that don't resemble us at all. Meaning, cyborgs, hybrids, chimeras of all kinds, augmented humans, augmented, biorobots. There's going to be all kinds of stuff in our environment. And if we don't, regardless of the software AIs, if we don't understand that we need expanded ways of predicting the goals of new composite systems that we haven't seen before, like that's an important science that we don't really have yet. And ethically relating to other beings that don't share a path on the evolutionary tree with us and have a completely radically different intelligence. If we don't wrap our minds around all of that, I'm pretty sure we're going to have issues. And it's not going to be just because of the software agents. It's going to be because of our inflexibility with dealing with radically different beings.
Yeah, so the premise of this existential threat, I believe, it boils down to this idea that we cannot imagine a different kind of intelligence other than ourselves. And we look at ourselves and we can imagine that humans could be essentially selfish and extinguish every other agent. So it's related to having this limited viewpoint or model of other intelligences, which is also the same problem that you're bringing up, which is if we don't expand that, then we're going to have a problem.
Yeah. I think we have to. I think we really need an education in this diverse intelligence, these ideas, and this is going to be required because there's all kinds of stuff coming, not just the software. Not there's the software version, and then Yeah, and I also see some people are really worried, sort of in the opposite direction. It's like, okay, if these things become that, I mean, I get email. I'm not even really, in that side of the field, but I get emails all the time. What am I going to do when the AI is so good at doing all the things that it's going to do? I mean, I think if we can't, if you can't do things just because there's somebody else out there who's better than you at doing them, I don't, I kind of assume that everything I do, somebody else is better at it. And maybe somewhere out in the world, out in the universe, there are aliens that are way better than us at art and, and science and whatever. Like, fine. Does that mean we're now, we can't, we can't go on and do our thing now? I'm not bothered by it. I I think that's fine. I think we can use it to raise our game as much as possible. Ultimately, very significantly, I think everything about us is ultimately changeable. Bring it on. I'm okay with it.
Yeah. So the expectation here is it's not just the AGI that's going to give us trouble. There'll be alternative or other biological general intelligence that will eventually prop up.
Yeah, I mean, already. So two things. One is, when people say, "Oh my God, we're going to make these incredibly intelligent agents and release them into the world," we already do that. It's called having kids. We already make, like, all the time, like, right now as we speak, somebody's making a really intelligent, a future intelligence with minimal control over its behavior, education, upbringing. Who the hell knows what it's going to do? Some of them do amazing things, some of them do horrible things. We already do this, so we already know how this kind of plays out with all kinds of consequences. And I think that within on the biological end, just imagine, right? You got over here, you've got a human being that's like 98% human, but there's a chip in his brain helping him control a wheelchair and maybe adding some IQ points and some stuff like that. Over here, you got a Roomba vacuum cleaner, and it's 98% robot, but yeah, he's got some human brain cells on board, cultured to help him get around the room, right? Okay, so 98 to 298, every possibility in between is a viable being. Every combination, 60-40, 50-50, like whatever. It's all up for grabs. So you've got hybrids where you've got living brains driving weird robotic bodies and new augmented prosthetics and new senses. If you want to have a sense of the solar weather, you can do that. If you want to have a sense of the stock market instead of smell, you can do that. Like, all of these things exist. All of these things already exist. So we're going to have these creatures. And then people will have, there will be hybrid robotics and kind of bioengineered beings that if you wanted to make a mammal with a third hemisphere, we can do that. We can graft on a third hemisphere of the brain. Why, no problem. We can make that today. So all of these kind of creatures are going to have novel bodies and novel embodied minds, and all of these old categories. It's a human, it's a machine, it's a robot, it's a living organism, it's intelligent. No, it's not. It's just like, all of that stuff is going out the window. I mean, it was never very good, but it's definitely not going to last the next couple of decades.
I don't think anyone's prepared for that.
Absolutely, they're not prepared for that. They're absolutely not prepared for that. They're not even prepared. They're not even prepared to think about it. I have constantly arguments with people who are still using these binary categories. It's just a cell. It's only chemistry and physics, but I am a human. Like, okay, let's follow you backwards. And guess what you were just, a few years and 9 months ago? You were a single cell, a little blob of chemistry and physics. So there's a smooth, gradual continuum, and there's no magic lightning bolt during any of that time period where somebody says, boom, now you've gone from physics to mine. That doesn't exist. So there's this continuum, and then I can stretch it, right? So I've got this slide where I show, okay, so there's a human in the middle, and up here, there's the evolutionary path, and you used to be a microbe up here, and there's a developmental path, and you used to be a unfertilized oocyte down here. And then you could go sideways, and you can do all kinds of biological modifications this way. You can do all kinds of technological modifications this way. All of this stuff is completely continuous. There are no binary categories anywhere. So when people insist on thinking, is it intelligent? Is it a machine? It's like I mean, these categories are worthless now. We have to rejigger all of that, and then comes the hard part of making the institutions fit, right? It's sort of like the notion of an adult, right? We have this notion of an adult. What's an adult?
Mhm.
Does anything happen on your 18th birthday to make you an adult? Nothing. We just have this binary cutoff to help to help the legal system figure out how you're going to get charged in court. But that's it. There's not really a sharp boundary there. So, I've talked to legal, kind of legal scholars and so on about how we're going to figure this out and what it means uh, to be a person. And these are not new. I mean, science fiction has been dealing with this stuff for 150 years. So these are not new. But I think now we're definitely getting to the point where we need to be figuring this out. And this AI stuff is just a tip of the iceberg on this.
Oh, okay. So all these other things would likely, if they're coming from biological material, would likely have some kind of agency greater than the kind of agency that we have for computers and deep learning systems. So you're assuming a world that all these things are autonomous and alive, I guess, have some sort of quote unquote free will to do whatever they want.
Yeah, I mean that's a whole other kettle of fish. When you look down, I mean, again, the continuum is really helpful. Like people say that doesn't have any free will; it's just a machine obeying physics. Well, if you look at a paramecium, what do you see at a single-celled organism? What do you see? You see chemistry and physics. You don't see any magic glow. And so some people will say, so then you can people go in a couple of directions, right? So some people say, okay, the paramecium has no free will or whatever, but I do. And so now you got a real problem because you were a single cell organism once. You were a single cell, right? So where did it show up? At what point? Nobody has a good story of where it shows up. That's one way to go. That doesn't work. So then some people go the other direction and they go, okay, fine. The paramecium does have this magical whatever because it's a living being, and machines will never. Well, if you look inside, right? If you actually look inside a paramecium, what do you see? You see a bunch of little cogs and wheels and things that grab onto each other and things that obey, the various pieces of physics. And that's about all you see in there. And I mean, right now we can't make one from scratch, but come on, there's no reason why at some point, right? Usually in the field of active matter and all of this, we can make things that do that. So I really don't believe that these binary categories are helping us. I think for all of these things, the question is what kind and how much, right? So when somebody says, is it intelligent? Is it cognitive? Whatever. I don't like the yes or no. I want to say where on the spectrum is it, how much, and what kind of problem solving capacities, how big is its cognitive light cone, right? That was the paper before the TAME paper. It talked about this notion of the cognitive light cone, which is the spatiotemporal size of the biggest goals you can pursue, right? So how big is your light cone? In what space is it? Is it in metabolic space? Is it in physiological? Is it in three-dimensional space? Like, where is it? That's what you really need to know. The binary categories don't really help you much.
But wouldn't civilization, I mean, the purpose of civilization is basically to ensure humanity's survival. Wouldn't civilization itself basically legislate that humans would be prioritized over every other general intelligence?
Well, there's
more of a legal thing.
Yeah. Well, right, the legal system is going to go crazy. I mean, it already has a million problems because of the Twinkie defense and things like this. Where if you really follow through neuroscience, the question is what does it mean that this person could have done otherwise? Well, what exactly does that mean? Given a kind of a materialistic view of the brain. So the legal system already has issues, but the issue of having of prioritizing humans suggests that we have again this kind of binary category of what a human is. So I think to a primitive early human, somebody like us, we've got some glasses, we've got some hearing aids, we've got some some shoes, we got a toothbrush, we got maybe an iPhone in our pocket. To them, you're not a human. You're a walking a multi-system, some kind of a like Like you're way beyond what a human is. I don't know, you know, you got all this other stuff. So that, and in the future, plus also a brain implant that gives you direct access to, you know, to a Google search and some infrared, you know, eyes at the back of your head. Like, so what? Are you no longer human? So that, you know, that's of course going to be argued in court. Somebody's going to say, listen, I may have tentacles and I may have a wheel or two, but what's wrong with me? You know, how come I'm not human? I have the same, you know, so that, and that of course also has been dealt with science fiction a lot. That brings up the question of, so what is an essential human? Like what is it to be a human, right? What do we want out of that? So let's run down the list. So is it the genome? I don't really care about the genome per se. Like that's, you know, some of these things, the thing to me is that like in pre-scientific times, you could have held the view that we are the pinnacle of creation. Whatever we have in terms of our body's limitations, capabilities, our IQ, our lifespan, our capacity for compassion, whatever it is, those limits were set to us, set by this like benevolent process, and those are the best they're going to be. Okay, so we're out of that Garden of Eden now, and now we realize that that's just where evolution left us. That's all. There's nothing magical or optimal about where we are. I don't believe. I think that evolution is this kind of like meandering sort of search process, and it happened to find that this particular form is good enough to survive and leave a bunch of offspring. Well, that's great, but I don't see any reason we have to stay that way. That it's arbitrary. And I like this notion of morphological freedom. I think each of us doesn't owes no allegiance to this random process that happened to have dumped you at this particular IQ level with this level of you know, damage or birth defects or whatever you've got. So that means, do I care about keeping the genome pure? No, I don't. Do I care about keeping the anatomy pure? We gave that up when we started using canes and glasses and things like that. I don't really care about that. There's nothing magic about this anatomy. I'm not trying to keep that preserved. What I do think we have that's kind of fundamental is in particular the cognitive, a minimal cognitive light cone as far as compassion is concerned. So what I mean by that is the moral ability to actively care about some degree of some quantity of other beings' well-being, right? And so that I think is what that level is what makes us human. Now going up beyond that, fantastic, bring it on. Going down below that, I don't think that's good, right? That's what I would argue against. So I would think that modify away, change whatever you like to give yourself a better life, to fulfill your you know, fulfill your potential. Just don't reduce your capacity for moral care. In fact, you should increase it. And this is an argument that we made with a few colleagues when we wrote that Buddhism paper. But the idea is, so that's, you know, that's what I'm interested in as far as humans. I'm not interested. I don't care what the genome is. All of this is completely arbitrary to me. How our genetics ended up, how our morphology ended up, you know, whatever. Let's improve it. But that cognitive light cone with respect to the compassion for others, that's gotta, that should only increase. I don't think we should be increasing it.
So your vision of the future of a civilization is that the citizens of that civilization would have a minimum light cone, so to speak, compassion light cone. Anything below the minimum compassion light cone disqualifies you from citizenry, so to speak.
Well, that's what we have. That's kind of what we have now, right? So if you're, you know, if you're a dog or if you're, you know, whatever, like you have certain protective rights, but you are not a full sort of member of society, right? And it just so happens, like I think one thing is that we are kind of special on this planet in the sense that it just so happens that there's basically one dominant species. Didn't have to be that way. Imagine that there was another dominant species that was like, I don't know, 40 IQ points lower. Like that would be a really tough case, right? Because, you know, not low enough that you could just say animals, but also not high enough that you want them running a nuclear power plant or flying airplanes. What do you do? Like that would be really tough. We're just fortunate here that there's such a gulf, right? So we could always say, oh, look, you know, there's this category, but it didn't have to be that way. So I see a future where we look like one of my favorite scenes is the Star Wars cantina scene, where right with this like every kind of alien, every kind of robot that things are on wheels and playing instruments running around. This is what the future looks like to me. I think that as long as you've got the light cone to participate with a degree of responsibility and compassion for others, you are part of the society. And then whether you've got wheels or you decided to have tentacles or a propeller on your head, that's that's going to be, I think those kind of people in the future, right? The future people are going to look back on us and they're going to look at all of our wrangling about gender and skin color and prosthetics and all of this stuff. They're going to laugh at this. This is going to be like hilarious. There's going to be such variety of embodiment at some point where you can pretty much live in whatever body you want to live. You can have more IQ. You can have a different kind of perceptual system. This is all of our wrangling over this stuff and what's a human and how it's going to be laughable. And that's one reason I really like the Star Wars vision is very much like that, where the friends with all the droids and all this. The in Star Trek it's kind of different, which I find just horrible. It's whatever the year is supposed to be, 2500 or something, 2400, and they're still arguing about what Commander Data's status is. Yeah, this guy, he serves on the Enterprise. They're still arguing about whether what his deal is. Hundreds of years later, I think that's ridiculous. I think that but within 100 years from now, maybe sooner, all of this will seem, assuming we're still alive and we haven't like blown ourselves up, I think all of this will be hilarious to people of that time.
But to have a civilization that accepts that kind of diversity, you would have to have some sort of guiding principle that says, okay, it's not acceptable to have just a single general intelligence, but we're going to accept all these kind of diversity.
I think we're well on our way, right? I mean, the principle, if I had to boil this down, I would say you want to relate ethically to someone no matter what they look like and where they came from. Does that seem radical nowadays? I mean, it used to seem radical. Nowadays, that doesn't sound so radical, right? And when I say where you came from, I mean, were you evolved? Were you engineered? There's some combination of. I think that principle would the young people of today do? You think they they don't find those two things? They don't find that particularly weird. This is, I think they just, I just think people haven't fully figured out what it means yet. But society's already going that way. You're not supposed to treat people worse because of what they look like or how they got here. We already know that.
Right, but the fear of AGI is that this other general intelligence could become super intelligence very quickly, would be a threat to our own existence.
I mean, it's not impossible that we engineer something. I mean, we did it. We put leaded gasoline and all these other horrible chemicals and a hole in the ozone layer. We did all this stuff to all that could potentially kill us all off without any agency in any of these things. We're all walking around with high levels of lead in our bodies because of all the leaded gasoline. The lead doesn't have much agency. It wasn't trying to kill us. We were just idiots. We did it to ourselves. And so could we engineer software agents and put them in charge of important things and have failure modes that we never anticipated and that screws us over? I think it's possible. It isn't going to be because of the intelligence. It's going to be because of our intelligence, not because of its intelligence. If we, yeah.